Welcome back to the CCA-F Learning Series from BornToSkill. This is Concept 5, Context Management and Reliability, covering Domain 5, which accounts for 15% of your exam. We have built the full stack: agentic architecture, human oversight, prompt engineering, and tool design. But all of that work, every conversation turn, every tool result, every retrieved document, has to live somewhere while Claude is thinking. Today we answer the question, how does Claude stay coherent and trustworthy across long, complex conversations? And what happens when the system that manages that coherence is not designed properly? Before we go deep, let us orient you in the course. Domain 1, Agentic Architecture, fully covered. Concepts 1 and 2 are published. Domain 3, Prompt Engineering, fully covered. Concept 3. Domain 4, Tool Design and MCP, fully covered. Concept 4. You are now watching Concept 5, covering Domain 5, Context Management and Reliability, 15% of your exam. A dedicated concept for Domain 2, Claude Code Configuration, follows shortly, completing the series. Right now, you are here. Let us get into it. Here is a question that trips up even experienced AI practitioners. If Claude answers each individual message correctly, why does a long conversation go wrong? Most people say Claude forgets things. That is true as a symptom, but it completely misses the cause. Claude has no persistent memory. Every response is generated from whatever fits in the context window at that exact moment. When that window degrades through accumulation, poor retrieval, or overflow, every answer that follows degrades with it. And the second failure is even more dangerous. A system that silently produces confident answers on degraded context is far more harmful than one that says it does not know. Silent confidence is the reliability failure that causes real-world damage. Context management is not a memory feature. It is the discipline of deciding what Claude needs to know right now. Reliability is the engineering of what Claude does when that is not enough. Let us go to first principles. Why does context management need to be a formal discipline? 3 reasons. First, Claude has no persistent memory between sessions. Every conversation starts from 0. Within a session, everything Claude knows is what exists in the context window, the active working space holding the conversation, system prompt, tool results, and any injected documents. Second, context windows are finite. They have a token limit. As a conversation grows, messages accumulate, tools return results, documents get retrieved, the window fills. When it overflows, content must be dropped, summarized, or compressed. What gets dropped determines whether Claude stays coherent. Third, reliability is the other half of this discipline. A model that silently produces confident but wrong answers on degraded context is more dangerous than one that explicitly says it does not have enough information. Reliability engineering means designing systems where Claude accurately signals its confidence level and fails gracefully when context is insufficient. Context management is the architecture of what Claude knows right now. Reliability is the engineering of what Claude does when that is not enough. The context window is Claude's active working memory. Everything Claude uses to generate a response must be inside it. It has 4 components, and they all compete for the same finite token budget. The first component is the system prompt. It defines Claude's role, constraints, and behavior for the session. It sits at the top of the context and is always present, but it always consumes tokens. A bloated system prompt is a context management failure before the first user message arrives. The second component is conversation history. Every message exchanged accumulates here. User turns, assistant turns, one after another. This is the primary source of context window pressure in long sessions. It grows linearly and cannot be stopped, only managed. The third component is retrieved context. Documents, knowledge base chunks, and tool results injected at query time. Each retrieval adds tokens. Poor retrieval strategy wastes context on irrelevant content. Filtering retrieved content before injection is not optional, it is essential. The fourth component is working memory. Chain of thought reasoning, intermediate steps, structured outputs in progress.
consumed during complex multi-step tasks, must be managed to avoid crowding out conversation and retrieved content. The key insight: all four compete for the same budget. Context management is the discipline of allocating that budget deliberately.
Now the second half of this domain, reliability. Reliability is not about Claude being right. It is about Claude being accurately right or accurately uncertain, never confidently wrong. 4 properties define a reliable system. Property 1, confidence signaling. A reliable system distinguishes between high confidence and low confidence responses. Claude should express uncertainty explicitly, based on the documents provided, or I do not have enough context to confirm this, rather than producing fluent but unreliable answers. Property 2, graceful degradation. When context is insufficient, a reliable system fails safely. It asks for clarification. It surfaces what it does know. It flags what it cannot confirm. It does not hallucinate to fill gaps. Graceful degradation is a design requirement, not a nice-to-have. Property 3, handoff patterns. In multi-session or multi-agent workflows, context must be explicitly handed off. A reliable handoff includes a conversation summary, key decisions made, open questions, and the state of ongoing tasks. Without this, every new session starts blind. Property 4, the anti-pattern to memorize, silent confidence. The most dangerous reliability failure. Claude produces a confident, well-structured answer on degraded or missing context. No hedging, no flags. The user trusts the response. The response is wrong. This is worse than an obvious error because it is invisible. Design rule: never confidently wrong, always accurately right or accurately uncertain.
Now, let us make this concrete. Imagine a large enterprise, 10,000 employees, that deploys a Claude-powered assistant to help staff navigate internal policies, HR procedures, IT documentation, and compliance guidelines. Employees interact with it in multi-turn conversations. A single session might span 30 or 40 messages. The same employee returns the next day with follow-up questions. The knowledge base contains hundreds of policy documents, some of which have conflicting or outdated versions. This is an enterprise knowledge management assistant. It handles context challenges that would stress any AI system. Long multi-turn sessions that push the context window to its limit. Large retrieved documents that compete for token budget. Cross-session continuity that has to survive between logins. Conflicting policy versions that cannot be left for Claude to arbitrate mid-response. And confidence under ambiguity, compliance questions where a wrong answer has real consequences. What breaks without context management, and what works when it is applied correctly?
Here is what breaks without context management. Scenario 1, context overflow. An employee spends 40 minutes in a session asking about parental leave, then pension options, then healthcare benefits. By message 30, the context window is full. The system silently drops the earliest conversation turns. Claude now contradicts its own earlier answers about parental leave because those answers are no longer in context. The employee files the wrong paperwork. Scenario 2, retrieval pollution. A query about the IT equipment request process retrieves 12 document chunks, 8 relevant, 4 from an outdated 2021 policy. The context window is now polluted with conflicting information. Claude synthesizes all 12 and returns a response mixing current and outdated procedures. The employee submits a request using a deprecated form. Scenario 3, silent confidence. An employee asks a nuanced compliance question. The knowledge base contains only tangentially related policies, no direct answer. Claude synthesizes a confident, well-structured response from the partial context. No hedge, no flag. The employee follows the advice. It is incorrect. A compliance violation follows. In every case, the model did not fail. The context management strategy failed. There was no plan for what to keep, what to discard, and when to say, I am not certain.
Now look at the same system, designed correctly. 4 context management patterns applied. Pattern 1,
Progressive summarization. Every 10 conversation turns, a summarization step compresses earlier turns into a structured summary block, preserving decisions made and topics covered while freeing context space for new content. Claude stays coherent across 40 message sessions without overflow. Pattern 2. Filtered retrieval. Retrieved document chunks are scored for relevance and recency before injection. Only the top 3 to 5 most relevant, most recent chunks enter the context window. Outdated policy versions are filtered at retrieval time, not left for Claude to resolve mid-response. Pattern 3. Confidence gating. The system prompt instructs Claude to signal confidence level, high, medium, or low, at the start of every compliance or policy response. Low confidence responses automatically trigger a disclaimer. Consult HR directly for confirmation. Silent confidence is engineered out of the system. Pattern 4. Session handoff state. At the end of each session, Claude generates a structured handoff summary. Topics covered, decisions confirmed, open questions, documents cited. When the employee returns, the summary is injected at the top of the new context. Cross-session continuity is preserved without raw transcript cost. Same agent, same knowledge base, completely different reliability profile. The architecture manages context deliberately, rather than hoping the window never fills.
Single-session context management is not enough for enterprise-scale AI systems. Real-world deployments require what architects call a memory hierarchy, 4 tiers of storage, each with different costs, capacities, and lifespans. Tier 1, in-context working memory. What is in the current context window right now? Fastest, most expensive per token, used for the active conversation and immediate task state. Tier 2, external retrieval through RAG, the knowledge base, vector store, or document repository, retrieved at query time. Cost is retrieval latency plus injected tokens. Must be filtered aggressively before entering the context window. Tier 3, session memory through summarization. Compressed summaries of prior conversation turns stored and re-injected at session start or at regular intervals. Preserves continuity without raw transcript cost. This is what makes long-running sessions viable. Tier 4, persistent external storage. Databases, files, structured records written and read by tools. Infinite capacity, 0 token cost. Requires explicit tool calls to read or write. The architectural principle is this: design systems so that only what is needed right now lives in the context window. Everything else lives 1 tier down and is pulled up on demand. This is the same principle as CPU cache architecture, applied to language model cognition.
Context management is where everything in this series converges. From concepts 1 and 2, agentic loops run across many turns and many tool calls. Each turn adds to the context window. Without context management, long agentic tasks degrade mid-execution, and the human-in-the-loop checkpoint decisions from Concept 2 depend on Claude having reliable context about what has happened so far. A degraded context means degraded checkpoint decisions. From Concept 3, the system prompt is the most stable element of the context window. It is always present. It always consumes tokens. Prompt engineering discipline directly determines how much of the context budget is spent on instructions versus useful conversation. A bloated system prompt is a context management failure before the first user message arrives. From Concept 4, every tool call returns a result that gets injected into the context window. Poorly scoped tools return verbose, irrelevant results that pollute context. Well-designed tools, minimal scope, typed schemas, concise outputs, preserve context budget. Tool design and context management are the same discipline viewed from different angles. Domain 5 is the foundation layer. Every other domain produces content that enters the context window. How that window is managed determines whether the entire system stays coherent.
Let us close with a clean definition. Context management is the architecture of what Claude knows right now. Reliability is the engineering of what Claude does when that is not enough. 3 building blocks. The context window. 4 components: system prompt, conversation history, retrieved context, and working memory, competing through a finite token budget. Manage it deliberately, or it manages you. The memory hierarchy. 4 tiers: in context, retrieval, session summarization, and persistent storage. Only what is needed right now lives in the window. Everything else lives one tier down. Reliability. 3 properties. Explicit confidence signaling, graceful degradation on insufficient context, and structured handoff patterns between sessions. Never confidently wrong. Always accurately right or accurately uncertain. And the anti-pattern that ends careers in production AI. Silent confidence. A fluent, confident, wrong answer on degraded context. Design it out. Every time.
That is Concept 5, Context Management and Reliability. You now understand the 4 components of the context window, the memory hierarchy that makes long-running AI systems viable, and how reliability is engineered, not assumed. This is the second-to-last concept in our CCA-F Layer 1 series. Coming up next is Concept 6, Claude Code Configuration and Workflows, Domain 2, accounting for 20% of your exam. It is the final concept in this foundation series, and it covers how Claude Code works in practice, claude.md/commands, hooks, and CI/CD integration. If this video helped you prepare, subscribe to BornToSkill for the complete CCA-F series. Like the video so other exam candidates can find it, and hit the notification bell so you are first to know when Concept 6 drops. See you in the next one.